Yeah, hi, welcome to everyone. So this session we will discuss B4 programming assignment solution. Yeah, so Sarnath, can you start?
Yeah, sure.
Oh,
I will start it. Just a minute. So I believe you can see my screen, right? And
yeah,
yeah, it's fine. So let's start it. So this is our problem statement. It just says that you have been dreaming of visiting Goa for a long time. You finally get a chance to travel from Mumbai to Goa by train. You're excited to book your tickets from Indian Railways, but when you reach the counter, you see the huge queue of passengers waiting for tickets. It is the holiday season and everyone wants to go to Goa. You join the queue and hope that it moves faster, but after a few minutes, there's an announcement that the counter will be closed for lunch break for an hour. Everyone are frustrated and worried that they might not get their tickets. Now, passengers do not want their time to be wasted by standing in a motionless. So we have something like a queue, and it just says that now there is a lunch and people are like they wanted to take a break. So these passengers do not want to wait by wasting their times. So let's see what they actually do. So what they do is they write down their ID numbers in front of them and behind them, not theirs actually. The ID numbers of people in front of them and the behind of them. Suppose this guy is of say ID number 1 and say maybe so 2, and this guy is of ID number 1 and this guy is of ID number 3. So we see that the person 2 actually writes the ID number of person 3 and person 1 in a piece of paper. So that's what it's given. Right? If no one stands before and if no one stands before or after the passenger, then they write down the number 0 instead. So if suppose this one, the person 1 actually writes 0 and then 2 maybe, and this person 3 writes 2 and maybe say 0. So this way they think that they can track their portion, but after the passengers return, it was actually very hard for them to find out who should stand and what should be done. So what's our task is we have been given these kind of sequences. We need to form the perfect sequence. So this is what our task is. So you understood the question, right? Everyone, like you can chat or use your mic maybe. So you can just yeah. So right. So now let's see what is the input. So the first line of the input contains the integer n, where n is like the number of maybe say passengers in the queue. Again, the following n lines follow. The ith line contains the pair of integers ai comma bi, where ai is the ID number of the person in front of the passenger and bi is the ID number behind the passenger. In some sense, suppose like I have 5 and 6. So, or maybe 7, and the person, I don't know, it's just maybe some random person X. So he just has his the number which is like the one who stands in front of him is 5. The one who stands in front behind him is 7. So he just writes it. And similarly, 5, suppose like writes, suppose this is the case, right? Just let me create up. So n, and suppose 2, 3, 4, 5, 6. So this 4 guy actually writes 3 and 5. This 2 guy, as is in the starting, he writes 0 and 3. And this 5 guy actually writes 4 and 6. And this 3 guy, he can write 2 and 4. And this 6 guy, he'll write 5 and 0, according to the question, where we have 1, 2, again 3, 4, 5. So always this is maintained, right? You understood this, right? So this is basically given, and what we have to do is we have to get the order. We'll be given this input and we have to get this 2, 3, 4, 5, 6. So any natural algorithm you can think of something. Anyone can try this. So anyone can actually answer if suppose have any natural algorithm. So this is one of the test cases, basically, which was believe given in the paper. So if it's not, maybe I'll try to explain it. So what can be done is we have this maybe say IDs 1, 8, 3, 6, 5. So we can split to sets. Yeah, let's see that. So we have this 1, 8, 3, 6, 5. And what it is given is this is the answer. Suppose this is the answer. So what can be our question is suppose suppose this 3 writes 8 and 6. And this 8 writes 1 and 3. And 0, 8. Maybe say something like that. So 3, 5, and yeah, I'll just take a new code. Right? Yes, yeah. So we have a suppose let's take an example of this one itself. So for yes, this is the x. Yes. So this is our input. So what is happening here is we have to like now say suppose we have 92 some random guy x and then 31. Then we can say from here is 7 is the second guy. As he writes, I mean 0 and 7. So 7 is the second guy from this. This is for sure. So always if we have 0 at the starting, then the second guy will be 7. And we can say this too. 31 is the second last number, literally. That also we can say. Because if it ends with 0, then 31 is the second last number and 7, 141. So 7, 145 in between some one guy, another guy is there. So now let's see that. Now if we see this, right? So with this, actually, we actually found it. Y7, W, 141. So these are our numbers because it just forms a sequence. Y7, W, 141. As this is just the intersection. Now we need to find just Y and W. So for that, what is basically happening? We know that now 141 is the last number just because we have just 4 numbers. This is the input. We have just 4 numbers. So 141 is the last number. So always like the second last number is 31. So Y7, 31, 141. So we got this. Now we need to find this. Now we have, now with this, we found that X is actually 7 intuitively. So now as X is 7, then Y should be 92. So 92, 7, 31, 141. So this is our output. So now we have to somehow convert this into algorithm and try to write it. And one such algorithm can be, I'll just maybe let's see. So we'll deal with it. So what I'm doing is I'll have 2 sets A and B. So what it does is this will actually capture the forward people, every forward people, literally. Whoever is standing in the forward, like suppose we have in our previous example too, where we had this part. Yes, so we just have the question always. So where we had like this part, we'll always store it in the A set, and the right side part, that is the behind people. We will store it in the other set called P. And we'll have dictionary or maybe say hash map in Java or any vector. I mean, I believe you can relate it with any of the language. you have a what is it, valued array where we store something like a of I to b of I. Something like this forward is the key and backward is the value. Something like 92, 31. In a second, I'll just say you why we can, why this can be useful and will fetch us the right result always. So something like this we can store. And this A set actually has, say, 92, 0, 31, 7. And the B set actually has 31, 7, 0, 141. Now, with these two sets, can you actually find the first element always? Can you find the first element? The first guy. So is it obvious? Like, who will be the first and last? Maybe not even first. We can find the first and last with these two sets. Any idea on this? Anyone can answer it? Is it obvious? Like, can you see something obvious that first and last element can be? We can see that the first element only exists in A and the last person only exists in B. So if we find A minus B or A this like minus B, A difference B, we can find the first guy, which is 92. And the last guy will be like B minus A, which is basically 141. So we got now the first and the last guy. So who will be the second guy? Second guy, with the help of the dictionary, we can easily say that the whosoever key is 0, basically the value of the 0 key basically will be the second person that we have saw just before here. Like we see that if we have 0, 7, it's going to be someone Y and then 7. And here there is no one before Y. So whoever has basically, if we have the forward guy as 0 and the backward guy as 7, 7 should be always the second guy. So the value of 0 is always the second guy. Do you get that right? So now we found 92, 7 and 141. So we need to now find the remaining elements only. So how can we do that? Any idea on how can we actually find the behind? And almost we have got the solution. So now we have to find only the remaining guys literally. So if suppose that's the case, like let me actually discuss the answer. What I'll do is I loop it. And what I'll do is, if suppose I have an array, like solution of, suppose I'll have something initialized an array of some 0 into n. So what I'll do it, loop it, and solution of I is equals to d of say I minus 2 or something, not I minus 2 exactly, but it's exactly like this, right? P of A of I minus 2. So something like this, right? This equation. Yeah. So sorry for that. So it's just d of solution of I minus 2. So why this happens? If suppose I have, let's say 92 is my first element and 7 is the second element. So now solution of my third element will be d of solution of my first element. So what is my first element? That is basically 92, right? So D of 92. So what is my D of 92? If I just check with the help of actually the 92, we can get all the, with the help of first element, that is, we can get all the odd elements, literally. 92 to 31, then 31 to 31 is the last, I mean, that's the previous last element. We have no other go. So here our example is so simple, because if we get the first element, if we get the first element, then implies we get all odd place element. And if we get the second element, we get all even place element. So then we can actually construct the whole cube again. So I believe this was understandable. With this, like, I can maybe show the code too. So in Python or C++, anything, it's basically I have a set and I have a dictionary in Python, and here I have a map in C++. Again in Java, again I have a hash map, and C, I believe I had a struct. So anyways, so what I am doing is basically I just input the values and then storing it into the dictionary D, and also adding the forward people in A and the backward people in the B. And then what I do is I actually get the first element, I get the second element, and then I iterate it and I fill it literally. I fill the odd elements and the even elements literally. That's what it's happening. And then I'm finally printing the solution. So I believe this is understandable. So if suppose people have any doubt, you can ask at any point. So then I can move to the week 5, right? It's just a minute. I'll just explain the week 5 programming assignment. So now let's check out the week 5 programming assignment. Yes. So we define number of people located in a queuing system, either waiting in a line or in a service. So, either waiting in a line or in a service to the state in the system at the time t. At t equal to 0, the state of the system is going to be equal to the number of people initially in the system. Two distant states denoted A and B are said to communicate with each other exclusively if bidirectional link path exists between the state A and B. In other words, the state A has a direct or indirect connection to state B and vice versa. If all states are pairwise communicable, then they belong to the same class. Your task is to find the number of such classes in the system. So if this is ambiguous, if these sentences are ambiguous, you can see the graph. So what it says is now 1, 2, and 3 are communicable, or they are reachable basically. So if they are reachable, they belong to the same class. And here 4, 5 actually know what to say, are in a different class, as 1 cannot communicate directly or indirectly with 5 or 4. We have to there is no path basically. So now this is actually class 1. So this is actually class 2. So the basic task is to find the number of classes. So if suppose we say in graphical terms, this is one component and the other one is the other component, we have to find basically the number of components in the graph to find out the answer. That's the output actually we need. We need the number of components in the graph. So I believe this question is understandable and it doesn't make any, toughness or hardness. Is it fine? Is the question understandable? Week 5 programming assignment 1. Okay, so if I want to, in what case I believe you are not understanding the question, can you explain the doubt? Suppose it's not. can use your mic to if everything understand. Okay, so you understood, right? So everything is, so I believe then can move to the next programming assignment question. Sir,
Yes, yes, yeah. Yeah, Puspendra, can you start?
Sure. I hope everyone is able to see my screen. Okay.
Yes, yeah.
So thanks for the confirmation. So the week 4 question is basically goes, we have a two-dimensional map, meaning like a two-dimensional matrix, and each in this x I comma j value has some value in it. Or what you have to find out is if Lucy, meaning if you're given, if you have to find out the value where you can collect the maximum resources. So the problem statement is pretty straightforward. Lucy has recently developed a fascination for battle royale. Help Lucy find the location on a two-dimensional map where she could parachute herself to and collect the maximum resources. So I'm not sure if anyone is a game fanatic or not. If you have a, if you play, if you have ever played COD Mobile, you get sort of an indication that the orange maps has the higher values for the resources. So it's sort of imitating on that sense. Uh, so what you need to figure out is that which is the optimum place where Lucy can land to collect the maximum resources. However, the movement of Lucy is controlled, that either it can move up or down, left or right, based on the location, and cannot move diagonally. So if you go to the next slide, if we choose a particular location, this I comma j, Lucy can move down in this location. She cannot move up because the value is 0 represents a dead zone. She Now she cannot move from this location to the left, for the same reason that this is dead zone. However, if she plans to move down, she can then move to the left direction because it's no more a dead zone. So you have to figure out so just movement. So Lucy moves from up to down, collects 3 plus 4 7 resources, then moves to the left. Yes, and the total resources is 9. Now, if you look at the essence of the problem is basically the sum of the values within the connected component. How do you define a connected component? All the values which you can reach from one index to any other, meaning any node is reachable from any other node within that connected component. And that's pretty much the essence of this question. So 3 is connected to this. This is one connected component. These 3 is one connected component. The other is this 2 and 4, and this is a single component which has only one edge there. So that is the problem statement in its entirety. Does anyone have any questions with regards to the problem statement? You can use either chat or your mic. Okay. Fine. Thanks for the confirmation, Shiva. Uh, so how do we want to proceed with this problem statement is very much simple. The only essence of this is I'm not sure whether everyone has gone through the week 4 lectures, but professor has given us the idea of how do you define a connect union to indices. So this is a Python solution what you have this is a simple union find collection, union find class, which keeps track of the parent, the rank, the set size, and the max size set. So this is the variables within that class. Now, first, what we are doing is that the because it's a two-dimensional index, first we are converting the, because we want to reuse the implementation which was given by the professor, what we are doing is that we are converting the two-dimensional array itself into a one-dimensional array. And if you look at this particular solution, the what we're doing is we're giving the index from so what we do is let me go back here. So this particular row has four indices, four values, and the next would be like fifth, sixth, seventh, eighth, and that is how you're converting a two-dimensional into a one-dimensional array, and that is how you can reach to any particular location. You multiply the number of rows, and you get add the column that you're interested in, and you get the value. So that is how you can transform any two-dimensional array into one-dimensional array and access their indices without changing any invariant from the underlying solution that we're using, which is your union find, which currently relies on just a one-dimensional array as keeping the parent and all this information. So what we do is that we create this particular object of the class. We assign the values in the assign size. We use the index, and we specify the value for that cell, which is defined by I comma j. And then what we do is we again all we have to now do is, because we have this created this one dimension, all we have to do is union those indices based on the up movement, down movement, left movement, and right movement. Once we are done with this, and now the union indices, how do they follow? They follow the same implementation that professor also explained, that first we check out whether the indices that we are providing for the union are live within the same set or not. If it does, we return it. If not, we find the topmost element of that particular tree, supposedly, and then we change the parent of X to Y based on the rank itself, where we choose the lowest rank so that the height of the tree doesn't doesn't increase by much. Then we increase the rank, then we update the set size, and then we figure out, because we have updated the set size itself, we include whatever is the maximum set size based on that value, if it is greater than already maximum value. And that's how you proceed with this problem statement. It's very much straightforward. You just have to sum all the values, find out the connected components, add them up, and get the maximum of those connected components. Any confusions with the solution? Okay. I'll take silence as everything is clear and no doubts. Okay, so I'll move to the week 5 problem statement. The problem statement is pretty much very straightforward. All you are given a binary tree, and what you have to do is print the sum of root to leaf path. So if you're given this binary tree, you have 3 leaves, root to leaf paths: 1, 2, 3, 1, 2, 4, 6, and 1, 6, 5. All you have to do is print the sum of all the root to leaf paths, and the constraints is that any value of that node, any node within this tree would have values between 0 to 9. where anything else? The first line contains an integer n. That's the specification of the input itself. You're given the number of nodes. You have 7 nodes within these. Now each of these are the values for the node, and so if you look at this, we have 7 nodes, and these are uh, zero based indexing, meaning so if I'm specifying this, the connection is between 0 and the 5th index. So if I were to give an example, not sure whether we have that. Yes, we have it already. So in this we have values 1, 2, 3, 4, 5, 6. Each has these indices, and the when we go to the specification on how the connection is between the left and the right child on this particular index value. So the next n lines, the zeroth index has left child as 1 and the right child as 5. The next value is 1, meaning this particular index has the left child of 2 and 3. Second parent index has no left and right child, and third has a no left child but has a right child on 6, and that is how you get this particular tree. And this is how you this is the explanation of what these root to leaf paths are. Just sum it up, and that is your output. Any question on this particular, meaning how what is the interpretation of these how these inputs are interpreted, and how the binary tree construction is done?
Yes, sir. Sir, the first line of third line of input which says 1 and 5.
Mm-hmm.
The left child is 1, right child is 5, but in the figure it is not 5, it is 6.
It is not 5, it is 6.
Uh, in this figure it is even 2 and 6. In the above figure it is something else.
You mean to say the 6, this particular value?
Yes, sir.
Okay, so the point is that these, so when you look at the second line, these are the values, actual values of each node, right? But
Yes,
when you
sir.
move on to the next n lines, those next n lines are the indices of from this particular array. Okay, and they are zero based indexing. So if I'm referring to particular one, I'm actually referring to this particular second value. What is this?
Okay, sir. Okay, sir. Got it.
This
Thank
one.
you, sir.
Okay, so when I'm referring to fifth, it means actually this particular value, which is zero. This is zeroth index 1, 2, 3, 4, 5. So this is the fifth index within this first line, second line of input I'm referring to.
Yes,
Making
sir.
sense?
Yes, sir.
Okay. Any other confusions or questions from anyone?
Am I audible, sir?
Yes, yes, definitely.
Sir, how is the 6 2 times? Like, are these the names of the nodes, or are they having some values?
This is, you can consider it as identifier as well as values, meaning this particular is giving you the value of each node. Okay, so if you look at this particular, how would you uh, give them an identifier as well as a value? So whatever values that you have are actually values of the node itself. Making sense?
Okay, sir.
So if I can repeat it again if you want, meaning what exactly how we are approaching this. Hello.
Yes, sir, got it.
Okay, so these are just values these are indices, but these indices are referenced as zero based. So when I'm referring to one, I mean this particular element. When I'm referring to fifth, is the fifth value index within this value. So that's why we can have repetition of values. Moreover, because we are restricting our values from 0 to 9 against each node, it would have multiple iterations of the same value. And -1 obviously represents no left child or the right child, depending on whether it's a first value or second value within those n lines. I hope I wasn't too fast in explaining this problem statement, and everyone is clear with this statement. And how do we want to?
Yeah, so you can you can consider as this indices as a ID of the node, and these are value actually inside the node, which we are using into the sum.
Yeah.
Okay. Yeah. These are values. Okay. 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 I think. Any query? Okay. So in B4, we have received some query about the correctness of some questions in the theory assignment as well as the programming assignment test case. So we are just verifying these questions, and after that we will take required actions for the re-evaluation. Okay. Okay.
Yes, sir.
Yeah. Okay. I hope. Yeah. That's it. Thanks, everyone. If you have any query, you can post on the Discourse forum or Google forum. Thanks.
Thanks, everyone. Bye bye.
Thank you. Bye.